Hi, MA114 students. Here's that screencast that I had promised on matrices. As you can see, I've got this is all in MS Word, so we don't have the good lines and all that, but it'll have to do because you guys know how well I don't draw. I don't draw very well at all, and but I figured this was clear and concise. And what I will do too is I will put this, I'll make this uh, file, MS Word file available on Moodle as well. So if you want, by the time this link is up, this uh, paper will be uh, available. So you may want to go to Moodle right now and click on this, get yourself a copy. I think it's 4 pages, so you may want to print it out even, and then follow along as we go along. Okay, I don't think there's too many errors. I double checked it, but we shall see, and I'll get my trusty glasses here to help me along with this process, okay? Okay, so there's 4 things we needed to know from 4.3, okay, which will be on the test. And the first one is we're going to have a 2 by 2 matrix, okay, just like that. And we're going to have a 1 and a 2, the second row, or column actually, and a 1 and a 2. Now they have A11, A12, you know, that's A row 1, column 1, A row 1, column 2. And of course, A row 2, column 1, and A row 2, column 2. The determinant of finding those is very, very simple. Okay, you just simply multiply the diagonals and subtract. So A11 times A22 and A12 times A22, and then you subtract them. Not bad. If that was all there was, we'd it'd be simple. Okay, so then we graduated to the 3 by 3 matrix, and we had to find the minors of all these uh, smaller matrices. You know, what we have to do essentially is just take a 3 by 3 and bust it into 3 different 2 by 2s. Okay, and that's how you find the determinant of a 3 by 3 matrix. But remember how I said we had that odd rule of, let me just make this big for just a second here. Okay, I plus j. I is the rows and j is the columns. So if it's row 1 in column 1, then that would be 1 plus 1. Okay, so what I came up with is a real quick way to do that. Now, when we go with the first one, if you stay with the top, okay, and see that first one, we're going to take these uh, 4 in the corner. And then when you take the second one, you take these 2 here and those 2 there, and you make a matrix. And then when you take this third one, you take the front 4 right there, which is right here. Okay. Now, if you don't want to remember all this I and J nonsense, what you have to do is you have to kind of get this down right here. This takes care of your minor business perfectly. Okay. And what you do simply is if you take from the top row, okay, top row, if you always find your determinants from the top row, then your first one's going to be positive because it'd be row 1, column 1, which is 1 plus 1, which is 2, and minus 1 squared is 1. Okay, so you don't have to do nothing. Then your second one will be minus. It'll change the sign. Okay, so if it's minus 2, it will become plus 2. If it's regular 3, then it would become minus 3. Okay, so you're going to change the sign of that second one because you're talking about row 1, column 2, and minus 1 to the third power is minus 1. So anything that's going to be is going to be times minus 1. So you change the sign. And then, of course, with the third one, you're back to row 1, column 3. Well, 1 plus 3 is 4. Minus 1 to the fourth power is a positive 1. So if you take from that top row each time, okay, all you have to do is remember to change the second minor. You know, flip the sign of the second minor. And you know, probably write this on your card. I may consider a half a page of notes instead of a card just to see where we go, just because this is so intense. okay? But that is a shortcut. Now, I'm not big on teaching shortcuts, but I'm going to in this particular assignment because when we start getting to Kramer's rule 2, it's going to be pretty heavy. We'll just need to know to switch that second sign in the matrix, okay? Okay, so that is the second way to find the determinant of a 3 by 3 matrix. Our third thing that we had to learn was Kramer's rule number 1, which again isn't going to be too bad. This is something like x plus y equals some sort of b, and so we had 2 equations, and then we find the determinant, which would be this part of the first 4, and then the determinant of x, which would be these back 2, and then the determinant of y, which would be this A column and C column. And then once we find the answers to these, then we will take that answer and divide it by the other answer. Okay, not bad, not bad. And again, if these were all we had to deal with, that wouldn't be bad either. We'd be all set. However, of course, you know, we're going to take this up a whole new level, right? Okay. We're going to have basically 3 equations and 3 unknowns, which is very much like those lines that we just dealt with the substitution and what like that. We'll use Kramer's rule again, and Kramer's rule is matrices. Okay, so we have to find the determinant of this 3 by 3, which is the ABCs. Okay, and then we have to find the determinant of x, which means you just put the d's in the first column and keep the b's and c's the same. Then you find the determinant of y, which you put the d's in the middle column, okay, and keep the a's and c's the same. And the last one is the determinant of z. You put the d's in the third column and that. So what we have now is we have 4 different 3 by 3 matrices to solve. And we were already kind of like, one 3 by 3 was plenty of work. Well, this is the big leagues. This is the big leagues, okay? And then again, once we get to the end of that, we will divide each one by the answer, and you'll get a numerical value for that, okay? So, the nice professor that I am, I figured I will help you do some of your homework this weekend because, why not? I ain't got nothing better to do, right? So let's do this. So I picked evens too because, what the heck, we'll help you get it done. And I'm going to see who actually does these and who actually doesn't. Because if you're struggling, but you went to the video and watched it and got the homework, well, there's your 4 done. So there should be 4 problems that were done for you. You shouldn't have even struggled on it because the answers are sitting right in front of you here. Okay. So I do sneaky things like that to see who's doing what because I love my job and I love you guys too. I want you all to succeed and do well in the class and move on and get good jobs and live good lives and everybody wins. And I like that scenario. So if I'm happy, I want it to rub off on you guys. So so let's take a look at some of these problems. Okay, we got find the determinant of the matrix -3, 5, 1, and 7. Okay. All right, we simply just multiply -3 times 7, and we subtract that from 5 times 1, which is -21, -6. Sorry, it should be -5. Look at that, typo already. It won't be there when you have your, I don't think I was wearing my glasses earlier. But -21 minus 5 is -26, and that is the answer, because I already looked it up in the book. Okay. All right, so let's do number 10. We'll do a 3 by 3. Yeah, we're still in the easy zone yet, right? Okay, so what you do is you work off that top row. 4, 1, 3. Those are going to be our minors. Okay, so we're going to pull that 4 out. We're going to pull that 1 out. And we're going to pull that 3 out. Because 1 is that second one, we're going to change the sign on it. Okay, remember from the rule up here. If you don't want to calculate I and J's, okay, I've already proven that it works. But if you don't want to do that, and I don't blame you, I wouldn't want to do it either, then you have to remember to change the second sign on that B right there, okay? So let me get back to, okay, so that positive 1, which is right here, becomes a minus 1. Okay, that's so we don't have to mess with i's and j's. Okay, and then of course the 3 goes right here, and then the corresponding matrices, 2 by 2s. Okay, now once we get them to 2 by 2s, you know what to do. Okay, so we have 4 times minus 2 times 2 minus 1 times 1 minus 1 times 2 times 2 minus 1 times 3, and 3 times 2 times 1 minus a minus 2 times 3, and then we just continue to multiply everything out. Go slow on these, take your time because you will make mistakes. I did. Okay, and just keep simplifying it, simplifying it, simplifying it, and simplifying it, and we get the determinant of 3. Okay, and I'm not going to explain all that, Matt. You know, we should be good enough. Not even though you'll make errors, you should be good enough once you get this one down. Okay, to be able to multiply that out. Okay, so the answer to number 10 is 3. Cramer's rule. All right, let's solve this by Cramer's rule. Now, this first Cramer's rule isn't bad, okay, because it's really all 2 by 2 stuff. We find the determinant. Okay, so we've got, this is your A1, this is your B1, this is your A2, this is your B2. Okay, and you find the determinant of that. And then with the x's, you replace the x's with the c's. And then when you get the determinant of y, you replace that second column. So what we have to find is 3 2 by 2 determinants. So the regular determinant is 5 times 4 minus 2 times 3, which is 20 minus 6, which is 14. Okay. For the determinant of x, we got minus 5 times 4 minus 2 times 11, okay, which is minus 20, minus 22 more equals minus 42. Okay, and then the determinant of y is 5 times 11 minus 5 times 3. So that's 55 plus 11. I'm sorry, 55 plus 15, which equals 70. Okay. Now we got to remember that x equals the determinant of x divided by d. Determinant of x was 42. Okay, so that goes on the top. Determinant of just the regular determinant was 14. So that goes on the bottom. And minus 42 divided by 14 is a minus 3. Same thing with the y. We take the y, which was 70. We divide it by the d, which was 14, and that equals 5. So our solution is minus 3, positive 5. Okay. So if we graph these two lines right here, you know, with or substitution or whatever, we would still get this same rule there, this solution. Okay, that's where these 2 points crisscross on the graph. Okay, so that's the answer to number 20. Look, I've done 3 of your homework already. Isn't that wonderful? And I'm going to do number 30, which is even cooler because this one's a lot of work. And then once you see it done, you'll know how to do these. Okay. Okay. Essentially, when you have 3 equations and 3 unknowns, you have a 4 by 3 matrix. Okay. And in order to find the determinant, you need to find the regular determinant of the front halves, the x, y, z's. Okay. And then you have to find the determinant of x, where you replace, you know, these back ones. You replace the front ones with these back ones here. See the 3, 2, 3? Okay, that becomes 2 minus 6, 0. And then you do the same thing with the middle column, but then you put the x's back. You do the same thing for z with the back column, and you put the y's back. And what you have now is 4 3 by 3 matrices to solve. Okay, so when we solve a 3 by 3 matrix, we take the minors. Okay, this is the one we're working on right here. We take that top row. Okay, and why do we take the top row, Mr. Sawaski? Because that way we can just minus sign that second value in the minors, and we don't have to worry about remembering I plus j or squaring or anything like that. Okay, so we take that first value, 3, and we times it by that little matrix, 3 minus 1, 2 1. See it right there? We take that second value, minus 2, but we know we're going to change that sign, so it's a minus 2. Okay? And then we take the fronts, 2, 3, and the backs, 2, 1. Okay? And then we add the last one here, which is a 1. So 1 times 2, 3, 3 minus 1. And then now, so we have 3 2x2s we got to solve for. 2x2s are easy though. So 3 times 3 times 1 minus 2 times minus 1 plus 2, I made that positive, minus a minus, so I just made it a positive now. Times 1 minus 6 plus 1 times 2 times minus 1 minus 3 times 3. Okay, and when you simplify all that, I get 3 times 3 plus 2. 2 times 2 minus 6 plus minus 2 minus 9. 3 times 5 plus 2 times minus 4 plus minus 11, which is 15 minus 8 minus 11 equals minus 4. So D is minus 4. Okay. So we go to the next one. We go to the X, and our X is way up here, but we're going to do the same thing. Okay. And you can see I have all these labeled out right here. 2 times this matrix C plus a minus 2. Remember, we got to switch that sign on that second one. If you don't want to remember I's and J's, then you've got to switch that second sign, and then you'll be okay for what we're going to do. Okay, I won't push it any farther than that, but you got to know that. Okay, and then 1 times 3 minus 6, and then we calculate all these out, just like we did with the previous one. They're all written here. And I simplified everything out, and d of x come out to 4. Did the same thing with d of y, and here's all the matrices. Remember to switch that sign on that second one. And look, we have 3 2x2s. Calculate them out. Comes out to 8. And last but not least, d of z. Here's my matrices. Okay, so you can write these all out, check them, and then you multiply all these 2x2s because 2x2s are easy, and it comes out to minus 4. Okay, so now we have to remember now that we have these all solved out, we have to remember that x is d of x over d, y is d of y over d, and z is d of z over d. Remember, we solved d equals minus 4, d of x was 4, d of y was 8, and d of z is minus 4. Okay, and so x is 4 divided by minus 4, which equals minus 1. Y is 8 divided by minus 4, which equals minus 2. And z equals minus 4 divided by minus 4, which equals 1. And therefore, our solution is minus 1, minus 2, and positive 1. Okay? And there it is. There's 4 of your homeworks done. All done. And like I said, I'm going to upload this page to Moodle, so you'll be all set. And hang in there. These aren't that bad. They're definitely better than story problems, but they are far busier than story problems. Okay, you got my sympathy on that, but these aren't really that hard. I know your guys' ability. I know your capabilities. I know you guys can do these. Okay, so go to it, have some fun, and we will see you in class.